Hello, my name is Ezekiel Yorke. I'm here to present a study on the improvement of a local manufacturing operation, where my fellow researchers and I looked at the deployment of lean principles and discrete event simulation. Now, upon hearing this title, one may ask, why this field of research? What's so attractive about it? Well, there are a variety of reasons, but three that stood out when preparing this research included the following. Between the period of 2010 and 2014, we saw an increase in annual revenue from TT dollars 702 million to 919 million. This was stated by the Oxford Business Group report in 2016, highlighting that Trinidad and Tobago was offering new potential in its food and beverage industry. Additional reports stated that the food and beverage industry in 2018 witnessed a 5.6% growth, which involved an increase in profit and production due to consumer demand. And thirdly, 30% of the overall gross domestic product, or GDP, in TNT is accounted for by the small and medium enterprises, or SMEs, and this is a place where many of the manufacturing industries locally are found. But what all of this meant was that something was happening. Progress was being made to contribute to the growth of the manufacturing industry. However, what happened? Despite the success, we've observed stagnation in the manufacturing sector, financial and infrastructural challenges in SMEs, and this has not boded well with increased competition on the global market. So to get an idea of what some of these manufacturing SMEs were experiencing locally, a visit was made to a local bottle manufacturing company, we're going to call them Company X for anonymity, to observe one of the important aspects that affects the profits generated by their company. And this aspect is called plastic injection molding, or PIM. Now, in addition to the definition that you see on your screen, this was responsible for taking the raw material called polyethyl terephthalate, or PET, and transforming this raw material into something called plastic preforms. Now, these preforms were the starting blocks or crucial aspects that would eventually become the bottles that you and I consume and use today, the bottles they'd create for their drinks. And upon observing the process and discussing with the quality control engineer and some of the technicians, what was apparent was a reduction in their system performance by 11%, such as the number of products coming out per unit time, and this was called the throughput. This was due to one of their two PIM machines being quite old, as much as 30 years old, and they were wondering, well, we're obviously losing revenue, but how can we fix this reduction? Secondly, the amount of preforms visually inspected versus that which was produced was quite low. Now, the reason for this was because they never really had a serious issue with respect to faulty products leaving their warehouse or reports from their customers. But since some of the mold cavities in their older PIM machine were no longer working due to its age, there was an increased level of concern of managing the quality of their preforms. And finally, there was a need to increase the capacity utilization of their PIM process. From the images on your right, you can see the raw material coming into the two PIM machines, M1 and M2. Now, M1 was a newer injection molding machine, but the older machine M2 suffered more waste in the form of non-value added activity, like an increased waiting time and more raw material that was still work in process. So these challenges, upon data analysis and upon understanding them, turned into possible opportunities for improvement. And with that in mind, more research was made to try and understand and solve some of these challenges. But how? Well, using a discrete event simulation software called Arena. The target was to virtualize a framework around the PIM system. Using key performance indicators or KPIs generated by this software, such as the value added time and like the processing times for each process, we would then observe the performance of the system in a virtual environment. Next, with the help of lean manufacturing, some of the strategies that researchers and practitioners have developed in this field would be applied to the simulation, tested and compared to the results of the existing system. This is what was used to formulate the aim, the objectives, and the expected project deliverables of this research, where the objectives were heavily tied to the preparations leading up to the simulation framework, and the deliverables had to do with the opportunities for improving the system that mirrored the PIM process of Company X. This was the flowchart that was used to virtualize the process by taking into account data such as the raw materials, where they entered, the resources and the processes and processing times. So the simulation model in Arena was created while the data you see on your right was integrated into the model. The runtime was set for 12 months to get an idea of what would happen over an extended period of time. And these were the results that were generated at the end of the simulation. But what stood out were the results of the value-added times and the waiting times compared to the total time of both injection molding processes, or IMP1 and IMP2, as shown in this slide. What was apparent was that the waiting time, or the time that contributed to nothing, was much greater than the processing times of both PIM machines. Not only that, but the waiting time for the inspection lines were almost as much as the value-added time for those same processes. And finally, the busy cost, or the cost that it took to run the older PIM machine, which was the Husky 300, was greater than the newer machine. This was an indication of what was observed in the actual performance and why the personnel were concerned about the system's health. So to tackle the bottlenecks that were found, 3 lean manufacturing principles were deployed, each of which represented its own strategy that was separately integrated into the simulation to generate separate results. The plan at this point of the research was to run different simulations with different data inputs that reflected improved conditions. For example, since the newer PIM machine had less busy costs than the older one, it took less processing time or value-added time per process, and using the knowledge of Heijunka, the older PIM machine was therefore replaced and simulated. Combinations of these strategies were then made to test and see if this provided any benefit to improving multiple challenges instead of just one strategy per challenge. This yielded observable improvements in the value-added time and waiting time, which was seen in strategies such as 2, where the waiting time dramatically reduced, strategy 3, where this happened but for the value-added time, and combinations of these strategies as well. Additionally, there was also a reduction in the busy cost, especially when using these combined strategies, while the work in process also reduced with these combinations. So in the end, it was possible to mitigate the challenges that were of principal concern in the actual system using simulation and aspects of known lean manufacturing strategies. With this in mind, more research is needed in this field, particularly when it comes to ways in which we can improve the system performance or the performance of SME manufacturing systems for a more sustainable future in this industry. Thank you.